See, the first isomerism is chain isomerism, right? So what is chain isomerism actually? In which the compounds, two or more compounds, are going to have the same molecular formula, but they will differ in the the nature of the carbon chain, right? Now what is the nature of, we know that we have mainly we have two kinds of nature of the carbon chain, that is the branched and straight. So they just differ in the nature of the carbon chain present in a molecule, right? So just look for example. For example, I have butane. So what is the formula for butane? Obviously but means 4 carbons. So we are going to have 4 carbons in a chain. I'll just satisfy the valencies of carbon. So this is what is the formula of butane, right? So if I wish to write the chain isomers of this butane, how I am going to do? I am just going to reduce this, so this is actually called as normal butane, because it is also one of the form in which butane exists in nature. So this is also one of the isomer called as normal butane. Now if I wish to write more isomers, what I am going to do? I am just going to condense this chain up to 3 carbon atoms. So obviously how I am going to condense? So that means I will be making 3 carbon atoms, and this 4th one from the terminal position, that means the CH3 group from the terminal position, I am going to shift this to a non-terminal position. That means I am going to link with some of the carbon atom which is present at non-terminal position. So here we have only 1 carbon which is present at non-terminal position, so I am just linking it here. Again I am satisfying the valencies. So this is something called as isobutane. So as you can see, they just differ in the nature of the carbon chain. Here it was straight and here it becomes somehow branched, right? So that means they exhibit the property of chain isomerism, right? Suppose the one more example, suppose I have pentane. So what is the structure of pentane? We know that we have 5 carbons in a parent chain, right? So this is a normal pentane, the straight chain compound, that is normal pentane. If I wish to make isomer of it, then what I am going to do? See, initially the chain consists of 5 carbons, so I am going to reduce it to the 4 carbons, right? So I have a chain of 4 carbon now, right? Now what I am going to do with the 5th one? I am going to shift the CH3 from the terminal position, either this or that, to I am going to attach it to any carbon which is present at non-terminal position. So here we have 2 carbons which are at non-terminal position, so we can use either of, right? So there is no hard or specific rule for it that you need to attach to this carbon or to this carbon, right? If there is specified that you need to make such kind of IUPAC at 2 position or 3 position, the methyl group is attached, then you have to consider. Otherwise, while making the isomers, you can attach with either of the non-terminal carbon. So what I am doing, I am going to attach with this carbon. So it becomes CH3. Again I am satisfying the valencies. So it becomes isopentane, right? So can I further condense it? Yes, I can condense it because it contains, see, the minimum of, you can say you cannot make isomers if the chain has less than 4 carbon atoms, right? And we can condense up to a 3 carbon atom straight chain. So that means I have one more chance to make it more condensed. So here I am just moving this methyl group to a non-terminal position. So what, like if I move this, so what non-terminal position do I have? It is the only this one, right? So what I am going to do, I am just going to condense this chain to 3 carbon atoms. This is already at here and I am going to attach it here. So after satisfying valencies, what we have? This, right? So what is the name given to this? It is neopentane, right? So these are the isomers in which you can say we have the normal pentane, we have the isopentane, we have the neopentane. What I have done actually, I have just condensed the chain, and we cannot condense beyond 3 carbon, right? Keep in mind. So if we want some compound to show the isomers, it is the condition that it should possess at least 4 carbon atoms, right? And we can just condense it up to the 3 carbon atoms, not beyond that, because after that we will be going to get the same kind of structure. So methane, ethane do not exhibit this, methane, ethane and propane as well, they do not exhibit this chain isomerism. Moreover, I have one more example for you. Suppose I have What is the name for this compound? As you all are familiar with the organic chemistry, now tell me what is the name of this compound. So how you are going to tell the name? You are going to get the carbon atoms. So obviously these are 1, 2, 3, 4, 5. And for 5, what word root we use? We use pent, and we do have double bond, and at one position, so it becomes pentene. Right. So, can I write the isomers for this? Yes, we can write, because there is no hard and specific rule that they should that the chain isomers are only shown by alkanes. It can be shown by any compound, whether it has a double bond, whether it has a triple bond, whether it has some functional group. That doesn't matter. What matters is the number of carbon atoms present in a straight chain. That I already told you that it should not be less than 4 carbon atoms. So, as you can see, they have 5 carbon atoms. So, obviously they can show the chain isomerism. So, see how I am going to condense the chain. I am now going to reduce this 5 carbon atom straight chain to the 4 carbon atom straight chain. So, this is what I have. So, now I'll be just what place I'll be assigning to the 5th one. I'll be moving that methyl group, because I cannot move this double bond, right, because we cannot change the position of the functional group. So, though we know that double triple bond, they serve as a primary functional group, so we cannot change its position, right, but we can change the position of the substituent, that is the methyl group. So, what I'm going to do, I'm not going to change the position of double bond, but I have the option that I can change the position of this methyl group. So, I'm just going to link this methyl group from the terminal position to a carbon present at non-terminal position. So, which carbon is present at non-terminal? Obviously this and this. To either of, I can attach this methyl group. So, what I am doing, I am just attaching to this one. You may attach it to this one, there is no rule for that also. It's your wish where you want to attach that. So, I am just satisfying the valencies. Sorry, CH2. So, this is actually the isomer of pentene. Now, I think you will be able to write the IUPAC for it, and that will be the name for this isomer. So, this is how I have shown you that you can just make the chain isomers by just condensing the chain. But 2 things you have to keep in mind, that to show chain isomerism, you can say the chain must be of a maximum 4 carbon atoms, not less than that, because meth, eth, prop do not show this kind of isomerism, because they cannot be further condensed. So, this is what is the this thing. And you know, when we compare the alkyl group with the alkanes, like if we wish to draw the chain isomerism of alkyne and alkane, so alkyl group are the one which show maximum the phenomena of isomerism if we compare it with the alkanes. Like if the alkanes show only 2, the alkyl group can show the 5. So, that means there is a difference between the isomers which are shown by the alkyl as compared to its corresponding alkane. Alkyl always show more isomers when we compare it with the corresponding alkanes. And moreover, we did in organic chemistry that we have primary carbons, we have secondary carbon, we have tertiary carbon, we have quaternary carbon. So, I think you remember, but still I will just review it. So, just look at the board. See, if one carbon atom is directly attached to one other carbon atom, it is said to be 1 degree. Right. If one carbon atom is attached directly to 2 carbon atoms, it is said to be 2 degree. If one carbon atom is attached to directly to 3 carbon atoms, it is said to be 3 degree, right. And if one carbon atom is attached to the 4 carbon atoms directly, it is called 4 degree. So, this is how we classify the carbon atoms of a chain as 1 degree or primary, secondary, tertiary, quaternary, or 1 degree, 2 degree, 3 degree, or 4 degree. So, just look at the board. If I want you to write the degrees in this, so how you are going to write? See. So, to how many carbon this CH3 is being attached? Obviously, to 1 carbon atom. So, it is 1 degree. And to this, it is attached directly to the 4 carbon atoms. So, it is 4 degree. And this again 1 degree, this is again 1 degree and 1 degree. So, likewise you can just put the degrees on the carbon atom present in a molecule by just looking at that how many carbon atoms to which they are actually attached. Now, we will start with the second type.